problem number 4919, we have to prove that set A union B equals B union A. And actually the same applies for A intersection B equals B intersection A. I'm not going to prove the second statement here. I'm going to focus on this first statement. You can do the second statement yourself if you want. Well, how to prove that? I'm going to split this problem into two main parts, on meta reasoning and object level reasoning. So at the meta terms, we can see that if X belongs to A and B, this is equivalent to the object level reasoning. In terms of object level reasoning, this is for any X belonging to some sort of universal set, such that the following statement, X belongs to A union B, holds truth, such that this one is evaluated to be true, right? For any X from universal set, such that this statement evaluated to be true. Therefore, from meta perspective, that would be equivalent to saying that, X belongs to A, or disjunction. I'm going to make it like this. Equivalence, logical equivalence to X belongs to A or X belongs to B. And now this is equivalent to saying that for X, A belongs to A, X belongs to A or X belongs to B. This is disjunction. This is logically equivalent to saying that X belongs to B, disjunction X belongs to A, which is equivalent to saying that for any X belonging to B or X belonging to A, this is logically equivalent to saying that X belongs to B union A. Therefore, we can conclude that for any X belonging A, X belonging to A union B, logically equivalent to X belonging B union A, which is equivalent to X belonging A U, equivalent to X belonging B U. Therefore, A union B is logically identical to B union A based on extensionality principle. Extensionality principle is something that I covered in my previous episode. You can take a look at that video to understand what it means. It essentially means that two sets are equal if and only if they have the exact same elements in both sets. Not only do we have the logical identity between two expressions, which essentially means that our commutator is 0, right? That these two values, they commute, that sets union is commutative. That also means that there is a formal proof behind that, because we just derived this proof. That's A union B is B union A. There is a formal proof behind this. So we kind of concluded that there is a formal proof in order to prove that these two sets commute, and at the same time we provided the object level proof behind this commutative property, and we concluded that at our meta level reasoning. So I broke this problem down into two parts. First one is the meta reasoning part. It's like a wrapper around our reasoning process. And the second one is the object level reasoning, which gives us very rigorous and detailed framework in order to see how these sets behave at the very lowest level, how individual elements behave, and how this logic acts upon individual elements of these sets. So you can apply the following approach in order to prove the commutative property of sets intersection. I'm not going to do that because it's analogous. You can do it yourself, and this is it for today's video.